Hello everyone, you are watching my YouTube channel Real Time Simulation World. This is engineer Sadakat Ali, and today I am going to start detailed modeling of modular multi-level converter in MATLAB Simulink. So in my previous video I have already explained about working of modular multi-level converter, about its control, its structure, its working principle, and all that I already explained. So today I'm going to start its detailed modeling. What is mean by detailed modeling? In detailed modeling, you have to design each submodule using discrete components such as switches, capacitors, and connect them to form phases. And each phase is composed of upper arm or lower arm connected by a conductor. So this would be a series of videos in which I'll explaining you that how you can model modular multi-level converter in MATLAB Simulink in detail. So let's get started. So first of all, you have to create a blank project, right? In which first of all, let's take a switch. You can use this IGBT switch or MOSFET. I am going with this IGBT uh, diode, IGBT or diode. Press, you can press Ctrl R to rotate this, right? You can disable this show measurement port. We don't need that. All right. You can adjust the size of this switch. Okay. You can copy this by simply press Ctrl and drag it. You can simply copy it. Okay. After that, we need a capacitor. For that, you can search for like RLC, and then you can just drag it down and select this RLC branch, right? You can rotate it, and you just have to open it and press C. Now this would be our capacitor. Click this, set initial capacitor voltage. Now since all the capacitors connected in this model will be equal, so for that reason we are creating a variable here. Let's name it CP for capacitor value, and this would be CV, capacitor voltage. So CP and CV, so these values will be used to change the value of capacitance if needed in future. So you just have to change this single variable, so it will automatically be updated in all the capacitors, and this should be CV. Okay, so it is showing this right because it does not know that whether the CP or CV are created. So you just have to create them right here. You just have to create a new script file, and here CLC and here all. Now here you can define what is CP and what is CV. Okay, so let's say let's say we are setting it CP as 5000 millifarad or microfarad, and CV as, let's set it 0 for now, and we have to save it. So we can save it here, named as parameter. Okay, so we have to just run it. So this is our CP and this is our CV. So now they are appearing, right? Now they are appearing. So we just have to enter CPCV everywhere. Okay, so let's connect this like this and connect this here, and you can simply connect it here, right? So this would be your sub module. Now you have to make copies of these sub modules. Let's say we are creating 4 copies. So once these copies are created, you can basically connect them. Now please note one thing, that basically the output of this submodule will go from here, right? Like each submodule will be connected through the second switch, right? So what you have to do is to connect this from here and this one here, right? No, sorry, not here, but it would be connected here and this one here, right? And then going to the next, we have to disconnect it from here. Now this will be connected here, right? And this one here. Similarly, moving downwards, we have to connect this here and this one here. All right. So we will take output from here, from this switch, and from this switch, right? So we can use like PMC port for that. Let's say this one, not appearing. You can simply search port. Yeah. So we can use this one as well, in and out. So this is basically required. So we can connect it here and we can copy it and we can connect it right here. Okay, next, simply what you can do is to select all this and just go here and create subsystem. So when you create subsystem, your all the submodules will look like this, right? So here you can connect This will be your, like, this will become your arm, either upper or lower. So we can go inside this. All right. Now you can delete these ports. You can delete these ports. Okay. After doing so, basically you have to measure the capacitor of each the voltage of each capacitor. You have to measure the voltage of each capacitor. So for that you have to connect a voltage measurement with each component capacitor. So let's enter voltage. So for the voltage measurement, we have, we can simply write voltage measurement. So we get this. Okay, so this is the voltage measurement, and simply we can connect this like this. Similarly we can connect it right here, because if you know that why we are doing so, because these capacitors will be charged and discharged simultaneously. So if the grid current is positive or negative, so we then have to simultaneously charge and discharge these capacitors. We also have to sort them, like the capacitor which is fully charged, we have to insert those submodules during the operation of MMC, right? So yeah, this is needed. Okay, next we have to here we have to select mux. We need a mux, and it should be four inputs. It should have four inputs. So here we have to connect each with this. All right. Next we can connect an output port. We can connect an output port with this. So this would be my output port right here. So it will out the capacitor voltages. All right. The next thing is we will have some. So I need a demux basically. So I need a demux, and it will have a four output. It will have a four output. So I can place it here, and I also need an input port. So I will take this and I will connect it here. After that, I also need a NOT gate, so I can write, or I can check it here. So I can use this and I can convert it to NOT right from here. Apply and press OK. Okay. So if you are familiar with the working of modular multi-level converter, so you know that if this switch is on, so the second switch should be off. So since we are having four signals, so we'll create a knot of each signal, and we will connect it with the subsequent switch. So we need at least four copies of this right here, and it will be here, and it will be here. Okay, so this signal will go here, and the knot of this signal will be connected with the switch below. Similarly, this signal will be connected with this, and the knot of this will be connected likewise. All right. So lastly, this one here, and this one here, and this one here, and this should be here. All right. So we have connected the measurement ports for the capacitors. We are measuring its voltages, and we have also connected the switching signals with the switches that will be generated later. So these are the inputs. These are the input ports where we'll connect this arm, and this input is nothing but the we can name it. Okay, we can later name this, or we can just click here, show block name, like this. So this will be our input, and this will be our output from this submodule. Okay, next, what you can do is basically you can create the copies of this. So let's say I'm creating a copy like this, right? So I need an inductor to connect. So I will do the same. Take an RLC branch and rotate it, and just select L from here. Okay, we don't need to set any initial current. So this will be the inductor L. Okay, we can also right here we can define the L. So let's say for now L is 5 millihenry, and run it. So L is defined. Resize it as per your need. Okay, now we can delete these ports. We don't need those. Okay. Okay. Uh, Next, what we can do is to basically we need current measurement for the upper and for the lower arm as well. So we can take current measurement. We can simply search current measurement, so we'll get this block. So we can take it, and yeah, we can rotate it like this. Okay, and we can simply connect it right here like this. So we need to measure the current for the upper arm and as well as for the lower arm, for the upper arm and as well as for the lower arm as well, like this. We can connect the current meter right here, ampere meter, and this will be right here. All right. Okay. Next, what we can do is to basically we can create the copy of this, but first we need to find the port, and it is here, connection port. So this will be connected right here. We need to define, it should be left, and it should be named as plus v VDC. Likewise, we can create a copy of this and we can connect it here, and it should be minus VDC. So this will be plus VDC and minus VDC. The next thing is we need to connect from. So these would be the gates. So we can make it like we u we upper a phase, we upper a phase. Similarly, we can connect right here, and we can name it as we lower a, VLA, right? So these are the measurements of the capacitors. So we can name it like, so we need go to, and we have to name it like these are the capacitor voltages. So we can say that these are the voltages of capacitors, upper arm and phase. So these are basically the phase A. uh, Let me change the convention of this. So these would be the gate signals. So basically I can name it as SUA and SLA. So these are the switching signals basically. So SLA and SUA, this looks fine. Okay, next I can name the below one as a VCLA, and also I have to make the scope is as global so that I can read anywhere in the MATLAB I want. Also this one I make it as global. All right. I also need to add some uh, go to and from right here. So I need go to for the current measurement. So I can name it as, first of all, this should be global, and then this is I upper and A phase, I upper A phase, and then I can copy it and connect it here. Basically I can add space like this. So this looks fine now. Okay, so SLA and SUA, right? Now I can make copy of this. So I can simply copy it and paste it here like this. So I can connect it right here, and I can connect it like this. Similarly, I can make one more copy for the third phase. Then I will change the name of those as well. Yes. So this is the third phase, and this should be here like this. Okay, so this should be the phase B. So S upper B and S lower B, and this should be I upper B, and this should be I lower B. All right, this should be BC upper B, and this should be VC lower B. Okay, all the names are changed. Likewise, I have to change the name of the third phase as well. This should be C. So SUC and SLC. Likewise, I can change the name for the current SIUC and I. This should be L, right? ILC. And similarly here, I have to make it like IL, ILA, and this should be L, not U. Should be lower arm, should be upper arm. Okay, the capacitors are remaining. So VCUC, right, and VCLC, lower third, right, VC upper arm third phase, and VC lower arm third phase. All right. Likewise, we can adjust these so that we can have enough space so that we can connect this PMC port right here. We can rotate it like this, and we can change the name of this. So this should be right first of all, and I can name it as A phase. So likewise, it should be B and this should be C. So I can connect it basically here like this, and I can make some space. I can connect it right here, and the last one is the third phase, and I can connect it right here. So let me change the name. So this should be B and this should be C. All right, now what I can do, I can select them right here, and okay, I have to select all and go to the subsystem. I can create here subsystem. So this looks pretty good. All right, so I can increase the size of this block. Now this would be my MMC, three-phase MMC, where I have to give this input, and this is my three-phase output. Okay, so next, what we can do, we can create uh, DC source for our model. For that, we can go to the library, we can access it, and we can write as DC. So we need to find a DC voltage source. For now, I am using a constant DC voltage source. Uh, in next, in future, I will connect AC to DC modular multi-level converter. So that will depict an actual picture of what actually an MMC HVDC system looks like. So I don't need these. I can delete now, and I can now here. Uh, First of all, I need to create a variable for this. So let me name it IVDC. So I'm making it 8 kV. Okay. Now here I need to define VDC by 2. Okay. First of all, I have to run this code so that these variables get loaded. Add to path. Okay. Okay. So VDC is loaded now, and it is 8,000. All right. Now we can make a copy of this, and we can connect this here, this one here, and this one here. All right. Okay. So we need to measure the input current for this DC current. So for that, we can search for the current measurement. We can take this. Okay. We can take go to. We can name it as IDC and global. Okay. And I can connect it here. Similarly, I need a voltage measurement as well. So this is my voltage measurement for the sorry for the input. So this is my voltage, and I can basically copy this and name it as VDC S. All right. Next, what we can do, we basically need to create. So I can delete these lines now. Next, I need a three-phase R resistance. So I can search RLC, and here I can get this three-phase parallel RLC branch, in which I can make it like, in which I can set it as R. So this is my R, and I can give it a value of let's say 3 milliohm. So 3 milliohm should be low. 3 milliohm. Okay, I can resize it according to my need. Next, I also need an inductor. So this is basically, you can say this could be a line model. Here I need to set L, and it would be same as the resistance 3 milliohm. All right. This looks okay. Okay, next we need to measure the output current of this MMC converter. So for that I can copy it like this, and I can place it here. Let me connect this. So basically we need to measure the output current, since we are going to control the active and reactive power. So we need to measure the input current, the output, the input voltage VDC, also the output current of the converter and output voltages of the converter as well. All right. So I can connect it here. Okay, this is done. I can make some space. Okay, for the voltage measurement, I basically need to measure the line and the phase voltages. So for the line voltages, I can connect it like this between phase A and B, between phase B and C, and between phase A and C. So this is A and this is C. So what I will get here the line voltages. I can search for marks and make it as 3, and I can connect it like this. Okay, I can take go to and name it as, so this is my output voltage of converter VCL. So VABCL, I can make it as global. Okay, this looks fine. Now we also need phase voltages. So for that I can copy these, place it here. Okay, so this is phase A, this is phase B, and this is phase C. All right, now I need ground. So I can give them ground like this. All right, so these are the phase voltages and below are the line voltages. I can copy this and I can copy this one as well and change its name to VABCP. All right. Now we need to take a three-phase source, three-phase voltage. So I can search as voltage source, and I need to go down. From here, I need to select three-phase source. This one. All right. I can rotate uh, its format. Click left, right like this. I can resize it and connect it like this. All right. So my base voltage is 25 kV. Let it be default. Let me set the frequency as 50, and for the phase to phase voltage or the grid voltages, so it should be 4.16 kV, and load flow is showing it is correct. Okay. Uh, okay, let me name it as 50, and this one as 4 4.16 kV. All right. Okay, we also need to measure the grid voltages as well. For that, we can copy this, and we can connect it here this way. All right, and we can use this basically, and we can name it as VABCG. So G for grid. All right. So our model is basically ready. VDC by 2 and VDC by 2. So our model is ready. Now we need to okay, the current, this one is remaining, this one is remaining, so we can take as mux. So this is A, and this is B, and this is C, and I can name it as I IABC. So this is my converter output current, and I can name it as IABC. Okay, so all the things are ready. Now we need to create its control. Okay, so our model is ready now. Now we need to create its control. So I will develop it in the next part of this detailed modeling of modular multi-level converter. Thanks for watching.